think this might be a challenge. Matt D'Amico from RetroBits sent over a Versa64Cart that was made by BWAC, and he didn't send over any instructions. Let's see if we can make it. Stick around. Whew, alright, VersaCart project. This was sent in by Matt D'Amico from the RetroBits channel. I will give you guys a link to that in the description down below. Thank you very much, Matt, for sending this in. What he didn't send in, and I ain't complaining, I'm just pointing it out, is the instructions are not here. So we got a 3D printed case, we have the printed circuit board, we have some diodes, some resistors, we have a chip socket, and on the back we have a flash ROM socket, some dip switches, a reset switch, a couple of shunts, aka jumpers as we all know, some pin headers, and a capacitor. And I think, if I'm looking at this board right, I think that I don't really need the instructions. Let's get the soldering iron warmed up. And while that's warming up, these are jumpers up here. So J6, J5. There's some jumpers down the side here, but these are the kind that you solder blob over. We've got R1, R2, R3, R4, C1, IC1, D1, it says optional for 16K only. This is, I can't read this. This is dirty. That's what makes it hard to read. Not my old man eyes. It says W27C512 457, I think. So this would be a 512K. So we're going to stick the diodes in and see what happens. We can always take them back out, but soldering iron's up to temperature. Let's get some solder. Let's get this thing rolling. We're going to see if we can do this sans instrucciones. So I'm going to do diodes first. They're the smallest pieces. And for diodes, there's a black line on the diode, and there's a outline picture of a diode where it looks like that black line should go. So that's fairly straightforward and obvious. There's one through the holes. There is two through the holes. Solder on the tip. Clean it up. Fresh solder. Clean that up. Grab my flush cutters. And some more solder legs to go. I'm going to touch up these solder joints because I can. Alright, 2 parts down. And then next smallest would be these resistors. I almost said capacitors. But good thing I didn't say it out loud. And the only thing I'm going to do with these resistors is make sure that the lines go in the same direction, because these don't really have a polarity. You don't have to retouch those solder legs, but sometimes I like to. It depends on how messy my cut was. And while I was doing it, my angle of attack on these 3 here with the soldering iron was so shallow that I actually soldered the open holes next to it shut with some solder that was on the back side of the iron. That's actually not a problem. It may be a feature. So what I will do is I will clean off my soldering iron and I will fix the light that I just dropped. Hang on. Okay, so that experiment worked out just fine, but what I should have done first was I should have straightened out these little elbows here. And there we go. It's installed, and that was a fun little experiment to play with. There's a lot of different ways to take care of that situation. What I could have also done is used some solder wick to remove it, or one of these solder suckers to suck out the solder, or even warmed up my desoldering iron. But, you know, sometimes I just want to play around and have some fun. Because that's what they say, guys just want to have fun, right? All right, reset switch looks like the next likely candidate. We'll put that in. Reset switch can only really go in one way because of the dimensions of the package, so you don't have to worry about that. And they're designed to hold themselves in place. This switch here next, and I'll show you a trick on these that I like to do. I will tack down one corner. Doesn't matter if it's in all the way or not, it just needs to be tacked down. And then I will hold it up in my hand, and it's probably fine already anyway. And I will heat that one up. Yep, it's fine. Which will allow me to seat that properly. And then I just go back through here and solder up all the rest of the connectors. Let's do these guys here next. So we need 3 for this set of jumpers and sets of 2. So I'm going to do the sets of 2 first. And then what I will do with these guys is I will install them like so. And then I will cross install the shunts on top of them to make sure that they're lined up properly. Hey, look at that. When you put it on the right way, it goes on much easier. And the point of doing that is to hold those jumper pins in place properly so that I can solder them on the back side properly. And I'm going to do that same trick where I solder down one pin and then warm it back up and get everything aligned properly. And I lost that light again. I will fix that after this video. Every time I go to put my soldering iron away, I hit that light and knock it off of the workbench. So there we go. There's a jumper pack installed. We have this one here to do, and I'm going to do something similar on this one, but not for the same reason. I'm putting this jumper on because these pins conduct heat into your fingers, and that's not fun. We're out of parts except for the socket and the ROM. And again, that socket has that same thing where I accidentally closed it off with a bad attack angle on the soldering iron. And you want to be gentle because you can actually push the pins back through when you do this. So that, for sockets, that might actually be the way to go. And I did wind up working on a project before where that was a fantastic way to go. So now I don't need tape, I don't need blue tack. I don't need anything. You know what I didn't do? Huh, just dumb luck. I didn't look to make sure that the notch was lined up. It is lined up. But you should make sure that notch is lined up when you go to install that socket. Everything that you do when you're soldering something together can be fixed if you do it wrong. When I first started soldering, I was extremely stressed out about getting all of this stuff right, but it's actually part of the whole technology. Like, I don't know if you can see this on camera or not, but there's a whole bunch of flux blobs all over the back of this. And so we get out a brush and some flux remover. I use this 4140A flux remover from MG Chemicals. And I dip this stuff in and I clean it off. And then to clean the flux remover off, I use some IPA. Isopropyl alcohol. That stuff smells good. The flux remover smells good. I'm sure the alcohol smells good too. Ta-da! Perfect. All right, let's get all that cleaned up, and we will work on the ROM chip next. I wonder if there's actually anything already on this ROM chip. This is BWAC's VersaCart 64, and the GitHub repo URL will be in the description down below, so you can go check this out yourself. This is a good place for you to get the Gerber files, to go have your own PCBs printed, your own printed circuit boards printed at your favorite PCB house, and it has all of the instructions for working with this thing. And this is actually a very versatile cart. I guess that's where the name VersaCart came from. But it will work with 8K, 16K, 32K, or 64K ROMs. I happen to have this 27C512 ROM, which is 64K. So I put two 8K ROMs and a 16K ROM on just to test. And there's a couple of things down here that he goes through on what to do. So when you download a CRT file, the first thing you need to do is run this cart convert program. This cart convert program comes with the Vice emulator, and on Macintosh you can get that through Homebrew by typing in brew install Vice, and poof, it shows up. And then you can find where it installed cart convert, and you can run this little tool, and it will convert the cartridge image file to a binary file that you can then burn onto a ROM burner. Since I did multiple ROMs, I needed to do this copy/B trick. I'll show you how I did that. So this is my handy dandy Windows XP virtual machine, and there's probably easier ways to do this, but I need to launch this virtual machine in order to use my TL866, and there's probably easier ways to do that. This is just the way that I do it. So here is the copy/B, and according to the documentation that I just showed you, there's this thing where a 16K ROM can't fall in between two 8K boundaries. So what I did was I took the diagnostic dead test cartridge and copied it twice. So I have the 8K file plus the 8K file, then the 16K file, and I copied all of those into one 32K ROM image. So copy/B, file name 1 plus file name 2 plus file name 3 space into your final product. I called mine combined.bin because I'm extremely creative and I do creative naming things. The /B is because you want to do a binary copy, and copy will not do that when it's doing this concatenation where it's combining these different files. It will try to copy them as text files, and you'll lose out on all of the binary data, and then things will be broken, and that wouldn't be good. So I took into account the fact that the Donkey Kong cartridge could not start on the second 8K boundary and put that diagnostic cartridge in there. I could have put Donkey Kong first and then the diagnostic cartridge afterwards, but it still would have wasted all of the extra space on here anyway. So this was just me trying to get this thing tested and figure out if it actually works or not. Now that we have the ROM image files converted from cartridge format to binary format, and we have them combined into a single binary, I load up my XG Pro, and I did this a little bit differently than Matt did in his video. In Matt's video, he was able to use the XG Pro program to stage all of the ROMs that needed to be loaded. I feel like that was a little bit more difficult than having it do it automatically, but there's more than one way to do it, and either way is perfectly fine. This is just the way that I did it. So I went up and I hit the load button here to load the combined.bin file that I just showed you. And then here I picked my IC, the W27C512, and then over here I hit the program button, tells me where to put the chip in, and runs through the whole thing. I've got a video on how to program ROM chips that I will link in the description down below. All right, let's get this thing all put together now. This little reset switch here is a little tricky, so I just turned it upside down to be able to slide it home. Gravity is your friend sometimes. There we go. On your finished cartridge, there are a bunch of jumpers and switch settings. I actually put mine in the same orientation. I put my word on up towards the top of the circuit board, which is the kind of the traditional way. The way that this circuit board is designed, it's just using like an off-the-shelf dip on-off switch package here, dip switch package here. Down is actually on, even though the word on is written up. So I might actually desolder mine, flip it over, and solder it back in so that on is now down and up is now off, because that has messed me up a couple of times. But what you'll need to know is that game and that ExROM, and then you'll need to know these addresses, and I'll show you a quick trick with the addresses. And then you'll need to know these jumper settings over here. If it's an 8K ROM, set it to switch. If it said ROM L in the text when you did the dump, you set that ROM L. If it's a 16K cartridge, you set it to 16K by hitting the 16K jumper and the 16K jumper right here. That's all there is to getting this thing set up. Let me show you the trick real quick. All right, so one more thing we need to do is start gathering some data as to what's going on inside of these cartridge files. And a tool inside of the Vice package is cart convert, like I had showed you before. Cart convert -F, which is like fill me full of info or find out stuff about this. Oh no, it's file, -F for file, and then the file name. That's what that is. So the cart convert utility -F for file, and then the file you want to look at. So for the diagnostic cartridge, we need to start writing down some data. And this is an 8K cartridge. I kind of already knew that because I can look at file sizes on disks because I'm a smart guy. But I do need to know this ExROM here and make a note that it's 0, and this game here and make a note that it's 1. And then this start is 8000, which means I need to use the ROM L jumper for ROM low. And if it wasn't 8000, you would use one of the other jumpers like ROM high. This one down here for the Donkey Kong cartridge is ExROM 0, Game 0. It's a 16K cartridge. Again, I already knew that. It starts at 8000, so it would also be ROM L. But because this is a 16K game, I can just put in that it's a 16K and it will boot up fine that way. So there you have how to get that information. I'll show you how to make note of this and what to do with this information in a few short... Just stick with it. You'll figure it out. We got this. Okay, so that trick that I was telling you about is to take that data that we recorded from before when we did the cart convert -F for fill me full of info and fill this table here full of info. So what I did, as I mentioned before, was I took the diagnostic cartridge image and I copied it twice. So there's actually two different versions, well, two copies of the same version of the diagnostic image on the Versa cart, and then I put the Donkey Kong image second, which takes up 16K, so it takes up 2 slots. So your offset here is 0, 8, 16, 24, 32, 40, 48, 56, and 56 runs to the end, which is 64. So this is all of the available address spaces that are inside of that ROM chip that we can talk to. This game and this ExROM is what I showed you on the screen. This ROM L is what I showed you on the screen before. When it's an 8-bit ROM, then you put switch, and when it's a 16-bit ROM, yeah, there we go. You put the 16K jumper on J5, and you put the 16K jumper on J6, even if it is a ROM L for the 16K version, it'll work that way. And then these are the addresses that you will put on A13, A14, and A15 for each of these slots. So if I want to boot up Diagnostic 1, I set the jumpers to Game on, which would be down, ExROM off, which is up, and then all 3 address lines are off or up, and then ROM L, and then switch for J5 and J6. And then if I wanted to do the second diagnostic image, which is a copy of the first one, I would do the same game, ExROM, ROM L, and switch, but then the addresses would be 0, 0, and 1. And then for Donkey Kong, it would be 0, 1, 0. And then if I had if this was an 8K image, and 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 this was an 8K. So you get the idea of how this table is filled out. This table will be down in the description below for you to sample as well. And then you can also kind of clone this into your own. This is just a word processor with a table in it. It's nothing fancy, or a spreadsheet, or whatever your flavor of the day is. And then the trick that Matt showed in his video was to print this thing out, fold it up, and shove it into some of the extra space that's inside of the 3D printed cartridge case. But I went ahead and decoded, with Matt's help, all of these address lines, so this way I don't have to think about this again in the future. There probably is some binary math way that you can do it. I'm not a binary math whiz, so I don't know. So I had to reach out and phone a friend, and thanks, Matt, for helping out. So what we've got here is a really cheap LCD television with RCA inputs, and then we have this beautiful Commodore 64 that was sent in by Don Digidio. I don't know how to pronounce his last name. I hope I got that right, Don. What we're going to do is we're going to try and turn it on first, verify that it works. Hey, it works. Awesome. It's a good place to start. Next up is the cartridge, and let's see, I've got everything set. Remember we said that on actually means off on this cartridge? There's the lens. Yeah, on actually means off. So I've got off, 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 on, off. So that's 0, 1, 0. And then I have these switches here set for 16K and 16K, which means this should be Donkey Kong. So let's turn off the machine and see if it's Donkey Kong indeed. Oh, that looks like Donkey Kong to me. Sounds like Donkey Kong to me. Dun 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 dun. All right, let's see if the reset button works. All right, reset button works. Let me consult my handy dandy table and get this cartridge reset over to the Diagnostic Setup. So what I did was I changed that to game on, and I set all the address lines to off, 000, and then over here, where is it? Can we get some light on that? Yep. All right, so the 16K switch for, let me see if I can read that, J5, for J5 is set to switch, and then this one here is set to ROM L. So let's plug this in, and it should be the diagnostic cart. Oh, that looks like the diagnostic cart. Does this machine still work? Maybe we should have started with diagnostics first. I guess we could make the thing. Pretty cool little 3D printed case. It has, if you're going to put in a single cartridge, it has the reset switch built into the cartridge. The VersaCart is actually a versatile cartridge. I guess that's where it got its name from. And it can hold up to 64K of ROM. So it's a versatile 64K ROM cartridge. And one of the things that makes it versatile is the fact that you can have multiple ROM images, and then you can pick which one you want to boot into. You can use different kinds of ROM images, different sizes of ROM images, and you could actually make something professional with this as the generic base. So you could hard solder the ROM on instead of using an IC socket, and then instead of using the jumpers or the dip switches, you could actually put solder blobs over. He's got little solder blob sections, segments, areas, locations, traces, I don't know what they're called, but they're on the PCB and they're there for you to use, so you don't need to use the jumper switches and so on if you wanted to make a game cartridge and ship this thing out. So links down in the description below. Thanks to Matt for the VersaCart and the 3D printed case, and to BWAC for designing it, and to my friend Don for sending in the Commodore 64 for repair as a donation to the channel. I appreciate all of you. Thanks for being awesome. There is a video right over there. Oh, no, different camera. There's a video right over there that I think you will find interesting.